Okay, so for 2A students, so I would like to explain the answer of chapter 2. Chapter 2, this is the unit exercise on page 64. Chapter 8, unit exercise, page 64 and onwards. I will explain most of the concepts and important concepts in this chapter, and I will help you on how to work on this topic. Okay, so let's work on true or false first. So current can only flow in closed circuits. This is about chapter 2. Chapter 8.2 current. Chapter 8.2 current, we always mention that current can only flow in a closed circuit, but current cannot flow in an open circuit. Okay, so again, for all students, I want you to write down the solution for all these true or false question. Okay. So these two questions cover chapter 8.2. So we can go to chapter 8.2 on the left-hand side. Chapter 8.2. Okay, this is current. So for the instrument to measure the size of current, electric current, we call this ammeter. Ammeter. It looks like this. This is the appearance of an ammeter. Okay, so we can say that this is a wrong answer. Wrong question. Why? Why is it a wrong question? Because the instrument is not called ampere. It is called ammeter. Okay, ammeter. So question 3, insulator is the basic process, basic concept. So we call this, for example, wood, cotton, plastic, they do not conduct electricity. That means they are electrical insulator. That means they have very high resistance. That's correct. True. The mains voltage in all countries are the same. This is not correct. For example, in Japan, they have 110 volts. Okay. But then in Hong Kong, we have 220 volts. Therefore, in all countries, in different countries, there are different mains voltages. So for overloading, remember this is unit exercise. Unit exercise, that means cover all the topics, all the sub-chapters in this chapter 8. So you have to sometimes flip to different pages to understand it. Okay. So overloading, we have covered that in chapter 8.6. This is page 129. Okay, page 129. When does overloading occur? Okay, overloading occur when there are too many electrical appliances connected to one main socket. This is dangerous. Therefore, this is question 5 is true. True. Question 6. A short circuit. That means you can take a look. Where's a short circuit? Short circuit on page 131. 131. The short circuit can result in a very large current and flowing through the circuit. So, and here, it means that when there's a path providing very, very low or zero resistance, the current is very large, result in a large current, so that will overheat the damaged circuit or even cause a fire. So this short circuit, this is a correct concept. So you also have to say where to find this concept. Okay, page 132. Okay, so next one, installing a fuse. Installing a fuse does not prevent short circuit. Does not prevent short circuit. First of all, I have to tell you the answer is false. Why is it false? Because installing a fuse, the fuse can only break the circuit when the current is too large. Okay, can only break the circuit when the current is too large. For example, when there's short circuit, we can break this circuit. But then the word prevent, actually the installing a fuse does not prevent short circuit from happening. So the word prevent is actually a wrong word to use here. Therefore, we say it's false. Okay, so 7 is false. For question 8, we install the fuse like this in this picture. And the fuse, let me see. Okay. In this picture, we show that when the current is too large and they go through the electrical appliance, so that current is too large and will burn the fuse, will blow out the fuse. Therefore, the fuse should be connected in series with an electrical appliance. Okay. When they are in series, the fuse can have the current flowing through a fuse is the same as the current flowing through the appliance. Therefore, that fuse can protect the appliance. Smaller wording. The current flowing through a fuse is the same as the current flowing through the appliance. Therefore, when the current flowing through the appliance is too large, the current flowing through the fuse is also too large. So the fuse will burn, and also to break the circuit. Okay, so question 8 we say is true. Okay, we say it's true. Question 9. If the current is exceeds the rating of a circuit breaker, so that breaker will automatically break the circuit. And so that means to reduce the current to 0. Okay. Reduce the current to 0. Therefore, by breaking the circuit, you reduce the current to 0. We do not say it reduce the current to a safe level. This is not a correct concept. The circuit breaker actually breaks the circuit. Therefore, question 9 is not correct, false. Question 10. Question 10, right here. If the earth pin on the appliance, let me find the earth pin. Here. This is page 128. Page 128. You imagine the appliance works well when there's a live wire connecting to the appliance and to the kettle back to the neutral wire. It does not need an earth wire to work well. The appliance still works well, even if we don't have an earth pin. Okay, the appliance still works well. Therefore, we put a cross there. Also wrong. Wrong concept. Therefore, it is false. Okay, for multiple choice. For multiple choice, whenever you see the word "or," then you think of any exceptions to disprove this sentence. Okay, all metals are conductors, yes, because they have electrons. They're free electrons. Statement 2 is not correct. All conductors are solid. For example, the metal mercury. The metal mercury is a liquid that can conduct electricity. Therefore, it's not a solid. Okay. All switches contain conductor. Yes. They contain conductors so that they can, when they're switched on, they can form a closed circuit. Therefore, this question we will say, okay, the answer is B. 1 and 3. Question 2. Which of the following make use of heating effect and magnetic effect of current? So in current, we are saying chapter 8.2. There are two effects. First one, this is page 91. Page 91 and page 92. Heating effect, that means produce heat. Okay, produce heat. And for magnetic effect, very often we say magnetic effect means produce some movement. Okay, so we want to produce heat and produce some movement at the same time. For example, hair dryer produce warm air, warm wind. Warm wind. The wind is the air movement. The warmth is the heat. So hair dryer is correct. The fuse is not correct. It does not make use of the magnetic effect. The electric fan also wrong. Therefore, the answer is A. Okay, so next question, we're talking about resistance. Resistance here. So for higher resistance, usually we talk about nichrome. Nichrome wire has higher resistance and copper wire has smaller resistance. It is on page, the summary is on page 111. Textbook, page 111. Okay, so the next part we have to determine which one has a higher resistance. For example, X is a longer wire. A longer wire has higher resistance. Okay, so X is longer than Y. You get what I mean? Also, the next part, a thin wire has a higher resistance. Therefore, thin wire, in this case, we mean the thickness of the metal block, Okay. X is a longer wire and a thinner wire. Therefore, in this case, we will choose X with the highest resistance. In Z, copper, the thickness of the wire, that means in this dimension, is very very large, it has a thick one, and also short distance to travel. Therefore, in this question, we will choose question 3C. Okay, so next one, question 4. Question 4 and this one. How do we give the dimmest light bulb? Voltage. So first of all, when we want to choose the dimmest light bulb, we want to find the one with less battery. 少啲電池. Okay, less battery. Okay. So for example, we'll take a look at C. Take a look at C. C has 3 light bulbs. C has 3 light bulbs. Circuit C has 3 light bulbs. Therefore, the highest. Therefore, its total resistance is the highest. Therefore, the smallest current. Sorry. Okay, so with the smallest current in the wire, when the wire there's smallest current, therefore the light bulb is the dimmest. Okay, each light bulb gives less light, give dimmer light due to the smaller current. Okay. Question 5. Which light bulb in the circuit below is the brightest? So all 3 bulbs are identical. Okay. If you remember in parallel circuit, so the voltage across branch 1 in red arrow, and the voltage across branch 2. So red voltage across branch 1 and 2 are the same. Voltage across branch 1 and 2 are the same. That means the branch 1 is the red one. Branch 2 is the green one. Okay, but branch 2, that means the green one has more light bulb. Therefore, it has a higher total resistance. Therefore, it has a smaller current. Therefore, it both like bulb B2 and B3 give dimmer lights. I expect you to be able to understand these concepts. Okay, if you don't understand, you can in the YouTube you can watch it slowly and replay it for several more times. But B2 and B3 give the dimmer light, but then for light bulb B1, okay, light bulb B1 with less light bulb, with fewer light bulb, the total resistance is smaller in B1. So the current is higher. So bulb B1 give brighter light. So I will choose A in this question. Okay. So direction, question 6 to 8 refer to this question diagram. What's the reading? Let me take note on those ammeter reading. For X, this is 0.5 A. For Y, it is 0.2 A. Okay. What's the reading of ammeter set? So in this case, X equals to Y plus Z. Because it is the main branch. In X, it is a main branch. And branching into two smaller branch, that is branch Y and branch Z. Therefore, 0.5 equals to 0.2 plus Z. And to solve this equation, you have 0.3. So I choose C. The reading of ammeter set is 0.38. Okay, so the size of the current passing through the battery. Let me draw here. Okay, pick a line. So the current passing through ammeter X is 0.5. It should be the same as the current passing through the battery. Also 0.5. I hope you would draw these notes on your workbook. Okay, so this answer should be B. Compare the resistance for question 8. Compare the resistance of two branches. Which branch has a higher resistance? So from the previous questions, you understand that set branch Z has 0.3 A. Okay. So you understand that let me type the note to you. Branch with Q and Z. Wait. Branch with Q and Z has higher current. Therefore, it means that there is smaller resistance. Okay. On the other hand, we can also say branch with P and Y has smaller current. Therefore, there is higher resistance. So I will choose, and this part I will choose A. Okay, so next one, question 9. Electrical appliances are connected in parallel to the main sockets. In parallel. That means, okay, let me give you the hint on this page, page 125. Page 125. Okay, so first one, they say all appliances can work at the same voltage. Yes, this is true. On the right hand side, I'm drawing the first branch, second branch, and the third branch, they have the same voltage. Therefore, statement 1 is correct. Okay, statement 2. Statement 2. Also correct. Each appliance can be switched on and off independently, like the switch number 1, switch number 1, and switch number 2, and the switch number 3. They can work independently. And the power, so for power, for the concept about power, we don't need to study about this. But then I can tell you statement 3 is not correct. So we will say the answer is A. For question 10. For question 10, I will draw here. So we want to find the light bulb that does not light up. In setup A, there's a short circuit. This line, okay, this line, this branch provide a pathway with very low resistance. So all of the current will pass through here. Okay, I need the smaller words. This branch provides a pathway with very low resistance. Therefore, they will go through the red line. They will go through the red line, but no current will pass through the green line. Okay, no current will pass through the green line, therefore no current will pass through light bulb through the green line, through the green wire. Therefore, the bulb would not light up. So I will choose A here. Next part, which of the question 11, which of the following is dangerous? How to judge if it's dangerous? So when we have a blown fuse, you have to choose a fuse rating like the original fuse rating. You cannot. How to choose a fuse? The fuse has to be right here. When you choose the fuse, the suitable fuse should have a rating or with slightly higher than the current passing through the electrical appliance. Therefore, this is not correct. You can just replace it. Replace it with the fuse with original fuse rating. Okay, you should not replace it with other fuse rating. So for touching the so this one is correct. This is dangerous. Statement 1 is dangerous. Statement 2 is also correct as dangerous because you may get an electric shock. Okay, we get an electric shock. Okay, last one also correct. When the appliance is switched on, you should not pull off the plug. Therefore, the answer is D. So for question 2, we do not test on this, so you don't need to work on it. Okay. Next one, unit and symbols. Write down the following names and units so you can follow the marking scheme. Current is ampere, A-M-P-E-R-E. Ampere with A. Voltage, we call this volt V. Resistance, we call it ohm, OHM. Ohm should be drawn like this. Let me draw with the mouse. Again. Okay, this is ohm. For power, you didn't need to learn about it. Power and electrical energy, you don't need to learn at this moment. So match the following. For cell, what is a cell? Cell, that means one single battery. One single battery, A3. 3. Okay, A3. Battery is the 4, IV. For C, switch. How does a switch look like? Switch should be, where's the switch? Switch is at that position. That's it. VII, that's number 8. Okay, for light bulb, you should have learned it. That's number 2. Ammeter, this is number 1. Ammeter is number 1. F, voltmeter. Voltmeter should be drawn like this. Voltmeter is number 10. This is X. Resistor is number 5. Okay, X, and this one is V. Last two, rheostat. Rheostat is number 7. And fuse is number 6. Okay, you can refer to your textbook if you don't understand. So name these circuit component below. I would like to, select a larger diagram. This is page 69 of your workbook. Okay. So for A, we call this the cell. Cell. Component A is a cell. Component B is a rheostat. Component C is a switch. Component D is the light bulb. Or simply, you can just say it's a bulb. Component E is an ammeter. So in the exam, please pay attention that this appliance with an A here. Therefore, it's measured as an ammeter measuring the size of current. So in the space below, you should be able to draw. You should be able to draw the circuit diagram. First of all, 2 battery, positive, negative, positive, negative, and draw the positive sign to me, draw the negative side to me. Make it clear. Positive side and negative side. From positive side, we can draw a wire going out. You can see a rheostat. Rheostat is the box. It's just a box with it's like a resistor with an arrow. Okay, with an arrow. So the next one you go through is a switch. Okay, from positive to rheostat, from rheostat to the switch. How does a switch look like? Switch look like a circle here. Okay, circle. And the next one is a light bulb. Light bulb look like this. Okay, light bulb. Also, the next one, we have an emitter. From light bulb to the emitter, emitter back to the battery. Therefore, we draw an A here. And draw back to the negative pole. Okay, that's it. Before starting the experiment, so this student, Frankie, set the resistance of the rheostat to the maximum. How does it set to the maximum? So please study the rheostat. Okay. So these wires below, has very high resistance. Wire with high resistance. Wire with high resistance. Okay, when you pass through a long distance and the resistive wire, so the total resistance will be high. Okay, so the sliding contact, just like in the workbook. In the workbook, when the sliding contact moves towards X, then the total resistance is very high. Just like the sliding contact here, when it's moved towards the left-hand side, the total resistance is always high. Okay, so in this part you should take X. Okay, when Frankie moved the sliding contact from X to Y, just like on textbook page 113. So when you move this sliding contact towards the right, so you pass through the wire through shorter distance and wires with high resistance. So it passed through shorter distance and the wire with high resistance. But then just went through this metal bar. Metal bar has much lower resistance. Metal bar has much lower resistance. Okay, therefore, with smaller resistance, in the answer, you should be able to identify with smaller resistance, current size. Ammeter reading, that means the current size is higher. Okay, so when the light bulb and this part, when the current is higher, so you can find that with greater current, so the light bulb will become brighter. So in this part, you can skip it. For kilowatt hour meter, we don't need to calculate. We don't need to calculate the power, so you can skip this part. Page 71. Page 71 states the variables for the experiment. So independent variable. We want to study the effect of changing voltage on current. Okay. For example, how to change the voltage? We can increase the number of cells here. We can add one more, we can add one more cell on left and right. Right? So the independent variable is voltage. Usually in this sentence, the effect of changing voltage. 改變電壓 changing voltage on current. We change the voltage first. And a dependent variable is something that we measure. We want to see whether there's any effect on current. Okay, so dependent variable is the size of current. So control variable, you can say the length of wire. You can say the resistance of light bulb. So question B, how we increase the voltage there by, now we just have one cell. You can connect more cell. Here, you can connect more cell here. So that you can connect more cells in series, of course, in the same direction. That means in the same direction, that means we have to connect positive at the left-hand side, negative at the right-hand side. Also positive on the right-hand side, negative at the right-hand side. Positive, left, negative, right. So when the voltage is increased, state 2 observation when voltage is increased. When voltage is increased, so we have ammeter reading increase. That means the current. Ammeter reading increase, second one. Then with greater current, the bulb become brighter. Okay. Almost the last question. So by plotting the graph like this, first of all, you have to draw an arrow on the graph sheet, graph paper, draw 2 arrows, and then you have to draw on the left hand side. Mention that this is the current. Also give the unit as 8. On the graph below, this is voltage. Voltage. The unit is V. This one's 0. Okay, for every 10 smaller boxes, we draw a mark, little mark there. Okay, and also for voltage, the same. It's the same. Little mark. Say 4, 5, and 6. Okay, so you have to specify when the voltage is around, when the current is the maximum is 2.4. So let's make it 2.5 maximum. 2.5, 2.0, 1.5, 1.0, and here that's one 0.5. So you have to pay attention that for regular interval, you only increase 0.5. Okay. Same as below, for voltage, the maximum is 6. You have 6 boxes below. Okay, so here we mark it as 6. And then 5. And next one is 4. This one is 3. Next one is 2. This one's 1. So put the first case. When voltage is 1.5 V. 1.5 V. Current is 0.6. You should be able to find here. So same as all other cases. When voltage is 3, current is 1.2. Okay. When voltage is 4.5, current is 1.8. Okay, and the last one. And then later, you can draw with a straight line passing through all of them. And the title, you should be able to write as a relationship between voltage and current in a circuit. Okay, from this graph, what do you know? From this graph, you will know that the higher the voltage, when voltage increase, from the graph, you also understand that the current also increase. Okay, from this graph. So the larger the current flowing through the circuit, okay. So, in this part, they also ask, why is it important to add a light bulb here? A light bulb here, because we can have some resistance here. With some resistance, we can limit the size of current in the circuit to protect the emitter. Okay, last two questions. So in this question, she wants to connect the like a matching question. Like from question 1, there's a wire connecting to the coating, so she can connect it to question to C behind the board. Okay, and with a closed circuit, they can form a light bulb. When the school student get the correct matching, then they can light up the light bulb, right? So, but then what's the problem? What's the problem? Because the problem will be about the copper wire here. Because they have no coating, they basically connect everything together. Okay, they connect everything together. So even if there's a wrong matching, the light bulb still light up. Light up. Even with a wrong matching. Correct. No matter it's wrong or correct matching, the bulb always light up. Why does it occur? Because there's a copper wire. The copper wires, they have no coating. Therefore, they touch each other. When they touch each other, so the circuit is closed. It's always closed. No matter which question and answer are touched by nails. No matter whether you answer okay, 1 and B or 1 and C or 1 and A, they always light up. Okay, so the last one, how to solve this problem? We should use copper wires with plastic coating. Okay. so each copper wire is insulated from each other. Okay. With such an insulation, these copper wire will not touch each other and will not connect together in the electrical current. Okay, so the last part. So the last part, okay. Here, to make the light bulb even brighter, so you can add several more light bulb. For example, okay, light bulb 1, light bulb. This is light bulb 1, light bulb 2, light bulb 3. Okay. On the other hand, when you want to add a light bulb that can be switched on and off during the game, we can say okay, so draw a light bulb here. Okay, draw a light bulb. Last question. Really, the last question. Why is the short circuit causing the fire? Because short circuit causes a large current flowing through the circuit, therefore producing a great heating effect. Okay, so one possible reason from the paragraph, because wire is loose and worn out. And part C, if the TV set has a 3-pin plug, what happens? So with a 3-pin plug with a fuse, these are safety precaution. How does it help? For example, when short circuit occurs, the large current will quickly blow out the fuse. When the fuse is blown out, the circuit becomes open. You break the circuit or you open the circuit, so current drops to 0. No fire would occur. Okay, fire would not occur. So this is the long video for explaining the question about Chapter 8 Unit exercise. If you have any question, then feel free to ask me.